So I'm going to slowly take a start. This is just a really brief introduction. I know before we get to Simon Scheider's talk on protogeography today, I just had a couple of points that I briefly wanted to go over before that. Shouldn't take more than a couple of minutes. First, welcome to everyone. Welcome especially to Simon, and thanks again for sharing this presentation with us. I also wanted to take the opportunity to welcome Xiaolong Wang as the Commission Vice Chair. He's very, very welcome, and I appreciate already his great help with the Commission. We'll be hearing more from him in the future as we work to enhance some of the Commission's activities in the coming months and years. Second, as I mentioned, there's a new Commission website. That website is available at geospatial.icaci.org. Mainly, this is a website to find out about events, past events that the Commission's organized, and future events that are scheduled. This is also where you can get direct access to the recordings, as well as a PDF copy of the slides, and also some literature that the researcher has recommended people might be interested in as well. In terms of the next speakers, I wanted to take the opportunity to just say that we're still looking for more speakers in this series. It's about presenting ongoing or recent research. So if you have any ideas, suggestions, or even just want to check with us about other ideas you might have, please contact Xiaolong or me. There you have our email addresses, and we would really look forward to hearing from you with your ideas and thoughts about future speakers. That was all from me. Now I'm really happy to turn this over to Simon and ask him to start his presentation. Simon, the floor is yours.
Yeah, thanks a lot, Francis. Just see, I need to. Sorry, I need to.
Oh, got it. I see that, but yeah, you need
yeah.
one more button, I think.
Yeah, right. But I can't reach the. Oh. There we go. Okay. Sorry for it. Okay. Thanks a lot, Francis, for this introduction and the honor to be able to present you a kind of as I said, intermediary work, ongoing work. I will say a bit more about this work in the course of this presentation, what it's actually about. I will also explain this rather complicated title that you can see here, Protogeography, a bit later in the talk. Content-wise, it's really about these three things: validity, maps, and questions. So that's basically the three concepts that I'm going to talk about in this talk. And I will start right away into an example. So if you look at this map here, which is a choropleth map that is supposed to represent the distribution of camels in Mongolia. And if you were asked this question here, where are camels mostly concentrated in Mongolia, probably most people would point to the center area in this map as an answer to that question, right? However, if we look at the details of how this map was generated, it was actually generated using regular hexagons, and where each regular hexagon just contains exactly 3 camels. And these regions, these colors, basically graded colors that you see in the choropleth map, were generated by just summing up the camels in the provinces of Mongolia, so to say, in this. So that's how this map came about. Now, it's probably clear to everyone who's familiar with cartography that this map basically fails to answer that question, right? The map cannot be used to answer this question, but the interesting question is why. So why can that map not answer this particular question? Well, if you go to the practical reasons why this, so well, we could say that this is a graded color scheme of corpus maps, and those graded colors as well as the question suggest actually a particular concept, namely a spatial density. For example, the question talks about concentrations, and corpus maps also suggest that actually. And that the map, however, was constructed using a different concept, namely the concept of a spatial sum. So what happens is there's a kind of a conceptual confusion there when interpreting the map and the question. So densities are intensive measurements, spatial sums are extensive measurements, and the problem seems to be that the question asks for an intensive measurement here. So that is basically on the practical level. I would say I would argue why this map cannot answer that question. And now on the more general level, what I would suggest, and that's basically the basic idea of this talk, is this why really on the more general level, you know, it relates to the fact that the map cannot be used because we fail to justify the answer using the map. So our justification of the answer fails in a certain sense, namely because we ask for an intensive measurement and we get an extensive one. Or basically, if we want to use a shorter word for fail to justify, we could say the map is invalid. So basically, that's what I mean with validity here. And you will see that that notion of validity that I'm using here is a very general one. It's actually one that basically we need to account for these kind of cases. We need a more general notion of validity. That's also one of the insights that I would like to argue for in this talk. Okay, if we take a look at existing notions of validity, so those notions of validity do not really quite fit with our purpose here. So validity, of course, is a very important notion. It is used in science. It basically makes science scientific in a certain way. However, if you look at the common definitions, there's a lot of vagueness, incommensurability, and actually also some problems of using those notions in cartographic, especially in cartographic practice. So we have a notion, for example, of construct validity, which can be defined as a test is valid if it measures what it is supposed to measure. Or content validity, a test is fully representative of what it aims to measure. The problem with these two definitions of validity is that it remains unclear who is supposing what measure and for what purpose, right? So what it is supposed to measure requires actually someone supposing a measure, right? Who supposes that actually? Then there's another notion which is called criterion validity. The idea there is that a model correlates with equivalent tests or gold standards. That's basically a kind of a data-driven approach towards validity based on ground truth. And there again, the question is, how do you choose ground truth in our case, right, of that map? There's also a notion of internal validity and external validity. So internal validity means a model corresponds to some kind of existing knowledge or experimental standards, whereas versus external validity, a model can be generalized to other cases. But then the question is how, when you're talking about experimental standards or experimental choices, how can we account for that aspect when talking about maps? Okay, let's take a look at another example to make clear what we mean with validity of maps. So how do we know this map here that you can see there? how do we know that map is valid in that sense that I was just proposing?
Okay.
I would say that the most important aspect of determining that is that we know that it delivers a valid answer to a particular question. Without knowing that question, actually, we cannot even start asking about validity. And that could be, for example, the following question: what would be the accessibility of postcode areas for ambulances in Rotterdam when closing the bridge over Haringvliet? So Haringvliet is actually this small bridge there that connects Rotterdam with Zeeland in the Netherlands. So the first aspect is we need to be aware of the question. The second aspect is we know that actually that map provides a valid answer, since we can use the map to justify the answer, and that justification in a particular case consists in knowing which experiments to run, actually. So that these three aspects, I would suggest, are basically that's what we need to know in order to know whether such a map is valid. And I will explain these aspects in the remainder of this talk. So what does it mean to justify, and what does it mean to run experiments? Before we go there, let's just take a short look at why existing notions of validity don't really work. For example, there's the statistical notion of validity, of content validity or criterion validity. Well, in this particular case, it fails, I would say, because putting that model to the scrutiny of as much data as possible does not really work. Why? Well, ground truth about accessibility is lacking, at least for future scenarios. And in fact, actually, this bridge, Haringvliet Bridge, has not been closed. So there's no data available that would actually validate that map. Furthermore, the same input data, the same map, can be used to answer different questions. And it depends on the question that you ask whether you actually have a way to assess whether the map can be valid. And also, in this particular case, we need to know whether the model fits our purpose and not whether it fits our data. So that knowing about the purpose is more important, actually, which is another reason why I think these all the notion of validity don't really apply. So what I would suggest is a pragmatic account of validity, a purpose-oriented account of validity that consists of these three parts. So the validity of a map is dependent on the questions asked, forming its information purposes. And then, of course, the interesting part is what kind of questions are we talking about? The second aspect is that, or the second hypothesis I would like to suggest, is to justify the answer using a map. That requires us to interpret the map into a particular conceptual model. Then, of course, the question is, which conceptual models are these? And another hypothesis is that those conceptual models are pragmatic. So that means that this map successfully substitutes a corresponding spatio-temporal experiment. In that particular case, for example, in the case of our correlative map, that experiment is an intensive or an extensive measurement. And then, of course, the question, which pragmatic theory would allow us to express that, to model that? These are basically the three things that I would like to, or the three hypotheses that I would like to defend here. They are part of a book that I'm currently writing, which is called Protogeography. And this term, this strange term, protogeography, it goes back to a strand of German philosophy, namely philosophers who are engaged into what they called proto-science. So that is the idea to reconstruct implicit know-how and the purposes of methods underlying a domain of science as part of a scientific culture, so including also the art of experimentation. And in order to make those this implicit know-how and those purposes explicit, and thereby amenable for critique, making them transparent, and so on. It's a particular school of philosophy called the Erlangen School or methodological constructivism. People like Paul Lorenzen and Peter Janich have established that school of thought, and they have themselves worked on things like protophysics, like protophysics of time, space, and mass, protochemistry, protobiology, protocognition, also proto-social science. And I think a similar program is really desperately needed for data-driven geography and geoscience in order to become explainable and valid, especially regarding GeoAI. Okay, so what I'm going to do in the remainder of the talk is I'm going through some ideas of the book, or parts of it are already were published also in papers, including a pragmatic knowledge model that consists of two parts, basically basic conceptual models of experiments. Then I'm going to talk about some information models like maps or charts. And then finally, I will dive into a model for the purposes of spatio-temporal models, which are basically questions. So what I will suggest is a question grammar, a preliminary one that captures these different purposes. Okay, so let's start with pragmatic knowledge and levels of validity. The most important starting point for this kind of approach is that we need to distinguish different kinds of knowledge. And the traditional way of dealing with knowledge is actually declarative knowledge, so knowing that something is the case, including inductive knowledge like data-driven research, deductive knowledge, or abductive knowledge. That should be distinguished from procedural or pragmatic knowledge, namely knowing how or know-how something can, or knowing how something can be done. Similar ideas were introduced, for example, by Gilbert Ryle already early 20th century. There were also some people in AI that picked it up. In our own field, Helen Kuklelis actually picked it up and suggested this basically pragmatics as a basis for spatial geographic information science. And also the sort that I'm using here is Peter Janich, who suggested a pragmatic view of information. And this is the idea behind this. It's basically a kind of a pragmatic action model that underlies information. That is consists of the idea that you have action schemas that can be actualized, and those schemas can have requirements and purposes, and the actions, the actual the performances can have conditions and results. And the example would be a carpenter, carpenter making a table, and in order to do that, there's requirements, for example, wood, or and then the interesting thing is then if the performance has succeeded, what that means is that the purposes have been realized by actualizing results, and that can be explained based on the fact that the conditions met the requirements, for example. There's also a notion of trans-subjectivity that these people have proposed, namely that all of this stuff is, so to say, reproducible within a community. So people, for example, people that actually learn that craft, they share that kind of know-how in terms of requirements, purposes, success, but also the schema, the corresponding schemas. And of course, they can fail also in their actions, right? Of course, an apprentice carpenter might fail to actually generate a decent table that is stable enough, for example. Now, the idea is that we use this theory, this amount of theory, and actually apply it also to information and knowledge. If we talk about knowledge, information, and data, these three levels there, we basically are also talking about actions. On the level of knowledge, we're talking about justifications, which are actions. So we justify claims. On the level of information, we talk about questions and answers. And an answer is informative because it actually answers a question. On level of data, we're talking about interpretations of science. And on all of these levels, we basically, validity can be defined based on whether those actions are transsubjectively successful. So whether we transsubjectively basically can reinterpret data, ask and answer corresponding questions, and justify claims. So what you also can see in this pyramid is that a lot of the know-how, the knowledge that we're talking about here, of course, includes implicit parts and explicit parts. And implicit parts, know-how, makes up a much larger area, so to say, of the knowledge that we're talking about. So most knowledge is implicit know-how because it has not yet been turned into a symbolic form. An example, how to miss a train in Greece. Well, we can miss a train on all of these levels, or due to all of these levels. For example, on the data level, because we misinterpreted symbols. For example, if you look at the clock and are unsure whether that time there, not the clock, sorry, on a board, and we misinterpret that time there in terms of arrival or departure time. On the level of information, it might be the case that if we're asking somebody about the time when the train is leaving, we might not get the right answer, the one that we're expecting, because we are not mastering the language. Or on the knowledge level, we might just run a failed experiment by just waiting until that time and see whether the train comes, and when the train doesn't come, our experiment has failed. So on all of these levels, basically, our actions can fail, and that basically corresponds to the validity criterion that we're using here. Okay, that is the notion of validity, that pragmatic notion that I'm using here. So what does that mean in terms of spatio-temporal information and maps? Well, let's first talk about the knowledge level. So I think the knowledge level really consists, when we're talking about maps, consists of conceptual models of experiments. Let me make that clear what I mean with this. So there's this famous paper by David Sinton from 1978 from the Harvard's Graduate School of Design, who basically proposed a kind of an experimental notion of spatial information, where you differentiate between measures, controls, and constants. So you keep certain things fixed during your measurement, you control certain things, and you measure certain other things. For example, in this tide gauge example that you can see on the left-hand side there, we're fixing a location. That's the location of that gauge. We're controlling time by moving a drum, and we're measuring the water height using a float. Now, we need all of these three aspects of information in order to make sense of a measurement. And all of those, so these different roles, really correspond to parts of an experiment, I argue. Sinton, in his paper, he suggested already that actually different types of maps can already be understood in this way, based on actually understanding, for example, in the case of the geological map, we would control the geological theme and measure the area that is covered by that geological theme. So in this sense, the map is controlled by theme and measured by and we measure a location. But also, if we think about core concepts of spatial information that were actually proposed by Werner Kuhn, I would think that we can understand these concepts likewise in terms of experiments. So if you think about that example here on the left-hand side, we're talking about, these are management areas of Amsterdam. We're talking about an experiment that controls certain types of objects and measures their shape or area. If we're talking about that concept in the middle here, which is the Euclidean distance from a road, we are talking also about, in the background, about an experiment, namely one where we control locations and measure the distance to objects. And on the right-hand side, there's another field-like experiment. As you can see, it is actually a different data format, but still a similar kind of experiment, namely one where we control locations and measure concentrations of NO2 in this case. What we suggested in the past already, for example, in the COSIT paper from 2024, is that basically any concept of spatio-temporal information can be somehow understood in terms of an underlying experiment. So, for example, our example of the ambulance travel times, in that particular case, we're controlling for origin objects in a network and measure distances. In that field example here, we are controlling locations and measure field values. In the example of that contour map, we're controlling value ranges of a field and measure the region that is occupied by that value range. And in the example of the trajectory on the bottom there, we are controlling for time and measuring locations of objects. So if we come back now to our pragmatic model, what that means is experiments are controlled action schemas that measure the outcome of some uncontrolled experimental process. So basically, it's the same schema, but we have an uncontrolled but triggered experimental process in between the experimental method, the experiment run, and the output. And in spatio-temporal experiments, these control the measures then basically these roles are taken over by spatio-temporal information concepts, in particular extensive and intensive measurements. To make clear what it means in terms of extensive and intensive measurements, because that was the example that we had at the beginning. So an example for the extensive measurement would be population counts. For intensive measurements would be population density. So how does that work in this particular case? Well, we have, on the one hand side, we have things that are part of each other, like regions and populations. So, for example, the Netherlands and Belgium, and in this case here, the Dutch and Belgian inhabitants that are populations. We call those things mounds. They are really, they can be part of each other. They follow a mereology, whereas the sizes of these things, for example, the sizes of these areas or the population counts are basically linearly ordered, so they are called magnitudes in our case. And you see already that in this case, what we are controlling here are regions, and what we're measuring are populations or population counts or area sizes. And now, extensivity as a concept can be defined based on these ingredients. So let's take the example here. We have here a region X and a region Y, and we measure their sizes, for example. And now extensivity can be defined by just saying that when we add up the sizes, the result will be the same as when we first merge the regions and then measure the size of that merged region. Okay, that property is called additivity, and a similar property can be formulated that is called subtractivity, and that basically can be used to define extensivity. So, and what that shows is that extensivity needs to be defined always with respect to a control domain. You see that? So domain A is extensive with respect to the control domain B under that measurement function if that function is additive and subtractive. To make an example, population counts are additive, right, in this sense, while population densities are not additive in this sense. So that makes one extensive and the other one intensive. So you see, the same experimental framework can also be used to explain extensive and intensive measurements. And not only that, basically you can use that notion also to define a lot of different types of relevant experiments that we are using when we are talking about, when we are interpreting maps. I just named here a few, and I would I refer you to these papers and also the upcoming book to basically get an overview over them. So including, for example, things like spatial fields, duration fields, flow fields, point flow measurement experiments, accumulation experiments, spreading experiments, regional flow experiments, lattice experiments, and so on. Okay, I will leave it with that because I can't really go into the details of these types of experiments. But the important thing to understand is that we can use that same schema to define and distinguish those experiments. Okay, so that's the knowledge level. When we're talking about the information level, we need to be talking about questions and answers. So how to match questions with answers, and how we use models or maps to give an answer to a question. So, for example, if we're talking about information models, we might be talking about bar charts, histograms, and pie charts, very well-known examples, and every one of us, of course, knows that these charts basically correspond to different purposes. The point here is that you can distinguish those purposes by understanding the question that you can answer with it. For example, the bar chart this particular bar chart answers the question, what is the amount of children for each type of pet? The histogram answers the question, what is the amount of people for each interval of travel time, that particular one? And the pie chart here answers the question, what is the proportion of English speakers for each country? You see, also in those questions, we have actually controls and measures, right? So we control, for example, the type of pet and measure the amount of children, and we control the interval of travel time and measure the amount of people. You see, the same structure applies there too. And of course, validity is related to that. So we can actually now talk about invalid information models, invalid bar charts, for example. They become invalid for measures that are not amounts, for example. Histograms become invalid for nominally scaled controls, as we know, because they need to be interval scaled. And pie charts become invalid for measures, for example, that are not proportions. And similarly, we can then talk about the validity of maps. In our example, that would be related to the question, what is the accessibility of ambulances for each PC4 area in Rotterdam? So here we are controlling for these areas and for the ambulance objects, and we are measuring, for example, accessibility. Now, the idea that we really need to understand in order to talk about validity of these information models is that those information models they basically represent an experiment, and what that means is just that they answer a question, a similar question, or the same question, so to say. So we can answer a question either by running an experiment or by running a model. And there's of course there's no one-to-one correspondence here. So we have a many-to-one relation. So for one particular experiment, we might use very many different models to answer the same question. So take the example here. What is the travel time to the nearest hospital for each home? We can either answer that question by running an experiment, for example, choosing homes and actually traveling to the nearest hospital and record the travel time, or we can run a model, for example, a network-based model by controlling input homes in that network and measuring distance over network, or by controlling homes and simulating travels over a network. And similarly, for a question like what is the temperature for each location, we might run experiments or run a Kriging model, for example. So the point here is that these models, they become models for those experiments because they answer the same question. And of course, we can use the experiments then to classify those models. So for example, this map here is a model that substitutes a capacity experiment in terms of our experimental schema that I was proposing earlier. Okay, the last thing I would like to talk about is how we can use all of that stuff in order to specify purposes of models, namely questions. So that's the idea, right? We have one of these models. Basically, the purpose of such a model is to answer a question, just like the experiment that is underlying it. And now the question, which types of questions, yeah, can we actually answer with our models? What I did together with Universiteit in previous work is we proposed a grammar for such questions, and that grammar consists at its core out of a grammar of spatio-temporal experiments. You can see a part of that grammar here on the right hand side. It's basically the context-free grammar that where you can compose by basically formulating a sentence, you can compose the corresponding experiment. So you see here that in this simplified scheme, we are composing an experiment based on choosing some measures and some controls for those measures, as well as a spatial extent. An example, here's a map of the proportion of amount of space of green. So basically the amount of green space for each neighborhood in Amsterdam. That green is, in that particular case, that's a map that was generated by one of our students in a course. And the task was to select green area below that river I that divides Amsterdam. And that particular sentence there, I mean, it does not correspond to, I would say it doesn't correspond to how you would probably naturally express this experiment, but it is a way to, it is understandable, and it basically is a way to parse that question in terms of the underlying experimental aspects, so in terms of controls and measures. So what you see here below is the parse tree. When you apply that grammar to that sentence there, you get that parse tree. Here's another example. That is the example of Haringvliet that I was telling you earlier. So where we are talking about a quantified amount of time to, for example, a hospital from each building, and the closest hospital here would need to be basically encoded in terms of a sub-experiment that is bracketed there. So in this case also can be parsed with this grammar. Okay, so this is the experimental grammar that basically allows you to express experiments. Now, in order to basically construct questions, of course, we need question words, and also ways to incorporate those experiments into the questions. And the way that can be done is, or what is important to understand is that for very many questions that we are using in geography, for example, or in cartography also, we think that actually we use experiments as action schemas, and those action schemas can be fictive, factual, or counterfactual. I will explain you in a minute what I mean with this. What I mean is that there are certain experiments that either are possible, or are, when they're counterfactual, we know that didn't happen, even though they could, or we know they actually were really performed. So to make an example, for example, for a projection question, we talk about a fictive future conditioned on a counterfactual present. So when we use a question like, what would be the case if? So in that particular case, that is a fictive future, and the counterfactual present comes after the if. A prediction is really a future conditioned on a factual present. So we know what is the case now, and then we predict the future based on that. Retrodiction means that we talk about a fictive past conditioned on a factual present, like, for example, what could be the case given that, or what could have been the case given that. A retrojective question talks about counterfactual past conditioned on fictive present. For example, what should be the case so that. I'll give you examples for each of these now, for each of these questions, and we see how basically the question can be constructed based on picking one of those patterns and then putting in some experiments. For example, our example again here. What is the closest ambulance station for each building in Rotterdam at present, given that the location of each ambulance station is such and such? Now, that is basically in this particular. So there's two experiments involved here. One including the location of these ambulance stations, and the other one is to pick out the closest station for each building. A prediction. For example, if we're talking about weather predictions, we could formulate the question in the following way: what will be the sum of the amount of rain for each location in Dortmund tomorrow, given that the air pressure and temperature for each location in Germany is such and such now? So there you see that the question is composed of what will be, and then the outcome of a spatial experiment later, given that there is a factual experiment happening with a certain condition now. Retrodiction, or we could also call that explanation. What could have been the event for each road intersection pair in Rotterdam last week, causing the travel time of this ambulance station to this road accident to be 30 minutes now? So that's a question, for example, used in accident analysis. Here's an example of a kind of a historical an analysis of historical analysis of language spread. What could have been the route for each language group in the Amazon starting 15,000 years ago, causing the location of language groups to be such and such at present? So what is the reason for the current pattern that we can see? So that's all examples for retrodictive or explanatory questions. And by the way, all of those questions are, so you can find these references. I put them there, so there's actual really experiments underlying those questions. Projection, so what if or scenario modeling questions. What would be the travel time from the closest ambulance station to each building in Rotterdam in the future if the travel time between this intersection pair was very high from now on? So for example, if you close a road, what would be the travel time to the closest ambulance station? That is actually the question underlying this network model. Or what would be the sum of the production of ethanol for each producer in Brazil in 2030 if the proportional amount of tax for ethanol for each consumer in Brazil was equal to 1.323 real per liter from now on. So that's part of a what-if scenario modeling model that actually that we cite there. It's actually an ABM simulation model in this case, yeah. Retrojection, what should be the location of ambulance station Rotterdam now such that the travel time to each building will be less than 14 minutes in the future? So that's a constraint satisfaction problem, right? So location allocation models have used these kinds of questions, and also optimization models use these questions. For example, what should be the location for each windmill of this wind farm now, so that the sum of the amount of energy for each windmill will be maximal in the future? Okay, so basically that is what I wanted to present. So what this is about, I would say it's a pragmatic model of spatio-temporal information, including also the information that maps contain, and about the validity on 3 levels: on data, information, and knowledge level. And I talked about an experimental question syntax that captures purposes of such maps or spatio-temporal models. And the idea is that the information validity of those models, of those maps, basically can be captured by that syntax, by understanding the question in terms of an experiment. So it's a way to specify purposes of maps in terms of the question that they answer. And of course, the opportunities consist in using that, for example, to select maps for a purpose, or to compare information purposes of maps. For example, that could be done by basically just comparing path trees of those questions. And on the knowledge level, so on the level of experiments, really, we are talking about the possibility to use such an approach to learn about the possible experimental validation strategy. So if you have a map, and if you have a question, and you want to actually assess whether your answer is valid on the knowledge level, you would need to run a corresponding experiment that answers the same question. Thank you. That's what I want to say.
Wow. Thank you so much for that wonderful presentation. I think there's a lot of questions I can imagine are coming. Some people might need, because the presentation was so deep and so many ideas in it, I think some people might need a little time, but still I want to check and see if anybody wants to ask a question already at this point. I raised my hand preemptively because I have questions, but I'm going to lower it now and see if anyone else has the question already to ask. Right. Okay, well then I guess I get to use my... Oh, Hong Yu, do you want to go first?
Sure, I can go first. Thank you, Dr. Harvey, for organizing this, and thanks for Simon for the presentation. I have a question. So it seems like you've already constructed a roadmap of checking the validity of geospatial questions. For future work, would it be possible to train and build an AI model that automatically checks the validity of questions people enter to the system?
So first of all, I would say when I'm talking about validity, I would always talk about validity of answers, not of questions. You can have a valid answer for a particular question, and that answer might be invalid for another question, right? So I would always talk about validity of answers, because answers are basically claims, right? You're asking a question and somebody actually gives you an answer, and that is a claim. And then we can talk about validity of those answers. Yeah? And then the question is, okay, can that be automated with AI? Yeah, so I guess that all of what I presented to you here is still on on the level of basically symbolic AI, because we need grammars and we need models to represent those experiments, or those underlying experiments that are represented by those models in an explicit manner. But once you have such a model, you can of course then train, use an AI to a machine learning based AI to basically train matches between questions and models in a controlled manner. The problem is that my argument here would be that this kind of stuff, this kind of matching is not easily doable if you don't have such a model. So if you just try to basically do this with AI on, let's say, huge corpora of questions, and the answers, you basically, I would say that you probably will not, you will fail actually to get those interpretations. But that's yeah. Does that answer your question, Andrew?
Oh yeah, definitely. Yeah, and I was just thinking, it will also probably be a challenge for the AI to differentiate the data format and data schema based on natural language. Yeah.
Well, especially because, as you can see, these, what I was talking about here are really interpretations of maps. They're not the maps themselves or the data sets that are used for constructing these maps. They're really interpretations of maps. So the interpretation is not it's not available on the surface of the data that is used there. So there's a lot of work involved in putting that information back, so to say, into the data, so that you could train an AI with it, right? So just using the raw data sets, for example, or just using the question itself will not give you that, I would say.
Okay, thank you.
Yeah, okay. Other questions? Okay, I'm going to go with my question. And Simon, as you can imagine, I'm going to take us back to 1975, to Sinton's paper, because I found it very interesting in your use of it, because I think that his scheme is very valid for a lot of things that we do with geographic information. It's maybe dated in some ways, but it's still a way to really think about what we're doing. But one of the things that Sinton talks about in that paper is, of course, that you have those three aspects, as I'm going to call them, of constant, control, measure. But he also referred them immer always to this the concepts of space, time, and attribute. So one could be space, could be constant, or it could be controlled, or it could be measured, and time likewise, and attribute likewise. But one was always going to be constant, one would be controlled, one would be measured. And that was the neat closure of Sinton's system.
Yeah, right.
And so what I wanted to ask is, in thinking about the semantical representation of information without the map, just as information, then do we need always, when we're looking at spatial aspects, spatial qualities, do we always not need to consider the way that whether we're talking about space, time, or attribute, to more rigorously tie it to sentence framework, although, as I said, we could discuss that too.
You will always need to basically go to that control concept. Yeah, so my argument there is that what happens there and why Sinton's approach is so interesting is because in my opinion, what he discovered is that we are interpreting the map or the data set which does not have that information in terms of an underlying experiment that we could perform. So the idea is that the controls and the constants and the measures come, so they come into existence by us interpreting the map or the data set, which is static, right? In terms
Yeah.
of a performable experiment that can be done
Right.
to basically verify the map. If you think about it, right, you can basically run. You look at the map, you can determine in that way, and then you could run an experiment in order to check whether what the map says is actually valid or not. So that's the idea here, right? And that idea that basically, so Sinton's, for example, is not explicit about it. He doesn't in his paper doesn't talk about experiments at all. And also, what is interesting also, because if you're looking, so what I've been doing in this book, I'm diving into literature on experiments, and how experiments are defined is in general in science, and you find those notions back.
Okay.
So those notions can be found back in experimental literature. So that's interesting, right? Right. So that's a hint that basically what is meant here is really a kind of a fictive or an actual experiment.
Yeah. Okay. So could you say already from what the work you've been looking into, what's the relationship between experiment and the more generic term that's often used in conjunction with geographic information as well as cartography, the use or uses?
Yeah. So I think so that we need to distinguish here that between, so to say, the level of the what I called here information model and knowledge. So information models can be used to, in my opinion, to answer questions. And a map is an example of such an information model, right? You can ask questions, and the map can be used to answer that. And so that is when we are talking about the level of information. Okay, so we're talking about questions and answers. And now, if we want to know whether our answer is valid, we would need to dive into that experimental level that is underneath it, right, underlying it. And the right. And so the interesting thing is that whether we're talking about static data sets or maps that are visualized or not, is on that level is not so important anymore, because I mean it is of course important in terms of how we deal with that information and how we make use of that map.
Right.
But always that interpretation is involved, and always it would lead back to, at some point, I would say, to those other levels. So my answer to your question is there's these different levels, and we need to know whether we're talking about that artifact, that map artifact, and its properties, and whether we're talking about that interpretation.
Yeah. Okay. I think I follow the point. Let me try to express it a little bit differently. That if we know the map, then we can understand the underlying experiment for which it is suitable and or purports to be suitable, and then we can assess its capability of addressing that. Exactly. To me, in my probably overly simplistic way of summarizing the points here, it's that comes back to use. I might come from use to experiment. I don't think I would go from experiment. Yeah, from use to experiment. I could do it reverse too. But I think in that sense, maybe the use is more a broader concept that's possibly people could go from use to schema without the concept of experiment, because for my lay understanding of the concept of experiment, I just don't have that breadth that you've been working on to think about, to work through the concept of experiment in the sciences. Or I wouldn't.
Let me say this. So you can think of those experiments as being also let's say based on each other, so they can be contained in each other. So you can run an experiment as part of another experiment, and so they can be can build on each other. And now, as I just said earlier, we can have representations or models of those experiments, and those models too can be built on each other. And that's what happens here, right? We have a map, and then we are doing something with a map to produce another map, for example, which is another model of another experiment that you might run independently. You see. So then you have basically a constructive layer of representations of models,
Sure.
right?
Sure.
And one of the experiments that you could run
Right.
for validating them. Yeah.
Yeah. Okay. I mean, to me, it almost seems like, you could use the metaphor of construction of a building, because for that, you just don't need to have the pillars. You need to have the walls. You need to have insulation, windows, flooring, et cetera, et cetera. So there's many constructions that go together to having the building.
Right. Yeah. Yeah. What is also, I think, what has been, in my opinion, what has been underestimated in the past in geoscience a bit in these representations. If you read through what has been written about representation in terms of maps or maps as representations,
Yeah.
is that there's so that seems to be always a kind of a yeah. So this this part of models is always mapped to those actions, those experiments constantly, and we make sense of those models by interpreting them back and forth.
Right.
So that's one of the reasons why
Mm.
I think semantics is so important, right? Because we cannot
Yeah.
just stay with the models and just whether they're maps or whether they're actually simulation models or computation models, doesn't matter. We cannot just stay with those models and then actually defend our claims or justify our claims just based on them. We have to always go back to that other side.
Yeah.
At some point.
Okay. Yeah. Yeah, interesting. I think it would be interesting to go back and think about Bertin's concepts and the critique of that too, because I think implicitly there's the attractiveness of Bertin for cartographers then as well as now was that he did present something that looks like a model but is very problematic when you actually try to use it.
Yeah, I mean, Bertin's talking about particular symbols that are used and are useful or useful for representing certain kinds of concepts. I think that is. I think that is talking about, so to say, the other side. So basically, really the representation side or the means of representation, right?
But he
And
was, yeah, but it's completely different way. Remember, he's like at the edge between an analog era and a computational approach. So what he's thinking about is like a re-engineering of the analog process using the first understandings that people like him had of a semiology and a functional semiology. So he is doing a type of modeling or attempting to do a type of modeling, that's for certain. But the complexities were and the demands of the practical requirements on the laboratoire where he was just demanded that he step back from the conceptual work, or that was his choice, to be honest. And he chose to focus on a pragmatic implementation, which is very, very important in the French cartography and geography world too today, in a way that it's very hard to assess in just an Anglo, if you just know the English translations of his work.
It's interesting to trace back actually this distinction between, let's say, that symbology or the discussion about the symbology and the conceptual part. Because if you are the interesting thing is that this concept of extensive and intensive measurement occurs in cartography as a concept, is in the background, so to say, in some of the criticisms of maps. But it seems to be very much related to just the representation of how that a choropleth map needs to have graduated colors and needs to be constrained in terms of what it represents. But actually, the underlying concept is really very general. It can be used not only in cartography, but also in geocomputation, right?
Yeah, absolutely. Yeah, that was. I'm just mindful of the time, and I just want to, because it's after 6, and I just wanted to check if anyone has other questions before we drift into a Friday afternoon mode where you can take your drink. I have a thermos full of tea still, so and continue for a few minutes if Simon's willing to continue. Otherwise, I think we would tie it up here. And But in any case, I want to thank everybody for their participation, and Simon especially for sharing this very interesting work with us.
You're welcome. I'm very glad that I had the opportunity to present these things. Yeah.
Yeah.
Oh,
Okay.
just
Well, I see first I have Christoph with a question, and then Hong Yu again.
Yeah, thank you. And yeah, thank you, Simon, for this great presentation. I have a two-level comment. One in direction of the past. Your framework is inspiring. Reminds me what the conceptual modeling community in database were trying to achieve 30 years ago. You know, at that time, people were designing very well-defined model, and part of the community was thinking of, well, should we also provide a model for representing questions apart from declarative language? But this was a failure, and probably because people was not interested. But anyway, now the other thing, you mentioned AI. In generative AI, we don't have any model. The information is a sort of mess. And there is an interesting direction at the moment where people are thinking about iterative questions, not just questions, but iterative questions being designed, manipulated, and processed by agent-based framework. And they are, you know, Jan LeCun and others are thinking of a sort of middle level where the information space, and in between the information space and the users, agents will be in charge of developing iterative queries, something somehow that can be an extension of what you are proposing. Does it make sense? What do you think, Simon?
yeah, absolutely. So Jan LeCun has actually written a very nice piece about for 2 years ago or so, a piece about why the current approach to machine learning is, in his opinion, bound to fail on a certain level, not entirely, but on a certain level, because of that lack of a conceptual model, that kind of a conceptual word model that can be manipulated in order to answer questions. And I think that is basically really what I would subscribe to here. So I think we need to basically use such models to supervise learning models, right? Because we want to make sure that they learn the right thing. And how do we do this? Well, we have the best thing. What we can do is we have a model that we can understand, that can be used to train and those machine learning models in a way that is understandable for us. I think a similar idea is basically, as far as I understand, is what he proposes. So I would agree to that. Yeah. That's a very good comment. Yeah, thanks.
There was another comment, but was it withdrawn? It looks like it was withdrawn. I was thinking, Christoph, if I understood and followed you correctly, then there was also the work earlier by, I believe it was Francois Genet, a historian, who found the limits with declarative models of information to be completely insufficient for the demands of interpretive historical research, and they developed with other people. He's not alone. Him and other people developed other models of representation of information for this hermeneutical approach.
This is in that direction. You know, practically, this can be a sort of extension of case tools, not only made of conceptual model, but also a way of representing queries, part of the model.
Yeah.
But this was not very much successful. People were probably happy with basics, SQL stuff, and so on. It was 30 years ago, so, you know.
Yeah. I as I follow the discussions in digital humanities, they weren't happy. but the majority of people in
Okay.
the telecommunications industry and the business wanted very much a transactional model where declarative knowledge worked very well.
Christoph, what I want to add to your comment, because you also mentioned the database community, right, that actually worked on query languages for databases, and that is and question answering to some degree. So my impression, I'm not sure whether that's true, but my impression is that one of the reasons why that might have failed is also because you need to really distinguish here the level of the representation of the model and the level of the actions, the experiments, for example, that you can run in all that are represented by the model. And that has not been really done consistently in these database communities, because what they are talking about is all the time the technicalities of the models that they manipulate, right? But they are models of something, right? And
yeah,
of what?
absolutely, Simon. Yeah.
Okay. Benner, I see you have a question.
Hi, thank you all. Simon, I'm a bit struggling with the way you use the terms valid and validity in connection with an answer. Because traditionally we would use it in connection with models, I suppose, and you always have maps and models, but a map is not an answer, right? And,
yes. Yeah.
And the model is not an answer. There's a difference there.
Yeah.
So you seem to be taking the validity from the model domain, let's leave the map out for the moment, and apply it to answers. So just to make up one of these Barry Smith type examples, if your map of camels was done correctly, the way you suggest, and we all know, right, with having the densities rather than the counts of the camels, but the data were wrong, and the density was 10 times as high as it actually is. Would you call that answer that I can get from that wrong map valid?
No, because so that's exactly what I was talking about. You have an information level and a knowledge level. So when we are talking about the question, the matching of the questions with the answer, we're talking about the information level. So on that level, that is a fitting answer, but the answer might still be wrong, and you find out on the knowledge level by running an experiment. So that's the point here. So you're jumping that then, so to say, from the information level to the knowledge level, and on that level, then you need to basically verify your answer by running an experiment. Okay, and then in your case, that would be then by measuring densities of camels.
I get that, but that seems to use a lot of words to answer or to evade my question of, is that map valid? No, is that answer, sorry, is that answer of the 10 times as high density of camels valid or not?
Yeah, yeah. Okay, you could directly jump to the experiment, you mean, or what's, because I think you always have these different levels involved. You need to first answer the question whether you basically you need to first assess whether your answer fits the question. If it doesn't fit the question at all, it cannot be a valid answer, right? If it fits the question, it might still be invalid based on the fact that it doesn't correspond to a certain experiment that you can run. So that's, in this sense, I think there are always these two levels involved. And of course, you could argue, well, let's just match it together and just have one thing there.
I get that, but at some point you're calling the answer with the wrong density, 10 times, whatever it may be, valid, right? And then you say, well, you need to run experiments, etc.
I didn't call that answer valid. I called the answer that doesn't fit invalid. That's a different thing, right? Because I said that that's an invalid answer. I didn't claim that the answer with that's the difference, right? I haven't claimed that basically if you're generating the answer with the right density, that's already then valid. That would require more, right?
Yeah, that's a bit, dancing angels on the pinhead. But why do you why do you want to use the term valid for the answer? Why is it not good enough to have it applied to the map and the model as we always did?
The map. Because I mean, so validity, what I want to make sure is that validity is needs these different interpretation steps, right? Because validity can go wrong on all of these levels. So that's the reason why I use these levels. I mean, of course you could actually simplify that model. I have nothing against that, but then you will not get different ways how it can fail, I would argue, you see? Because it can fail already on the level of the question and the answer that doesn't fit. It might also fail on level of the experiment.
Yeah.
I hear what you're saying. Thanks.
Okay. Great. And I think we'll take a lot of what you said today with us, Simon. Again, thanks many, many times for that really interesting presentation. I would like very much to thank you very much. As I noted before at the beginning, that there'll be a recording of this made available in the next days or weeks, for fast enough. And for after that, then if you have any questions, please let us know, especially contact Xiaolong or me if you have any proposals, suggestions for the commission or otherwise. I think I'm seeing there's 2 other messages that came in the last minute. Yeah, thanks. Thanks, everybody, and have a lovely weekend. And I'll send a message to everyone when the video is available. Okay?
Thanks.